Okay, so that last video cut out on us. We were right at example 2, step 3. And step 3 has us plugging in for our 9th term. So we want to find a sub 9, which is our 9th term. And how we do that is we take our rule that we have previously found and we plug 9 in for our n. So a sub n, in this case is a sub 9, is equal to 22 minus 2 times 9. And if we take those numbers and simplify, that's 22 minus 18, and 22 minus 18 gives us 4. So our 9th term is going to be 4. And we can actually go through and we can keep subtracting 2 9 times to make sure that our 9th time is 4. But if we were looking at the 100th term or millionth term, obviously that would be very tedious to do that over and over again. So these rules help us plug in and figure out what our nth term is down the way of our sequence. We can also double check our answer because our sequence here is getting smaller because we're subtracting 2 from each of the previous numbers. So it makes sense that our 9th term, which is further down, is actually a smaller number. So you may want to double check to make sure that your answers do make sense in the very end. Now let's move on to example 3. Example 3 is very similar to the previous example in lesson 1. Example 3 is asking us to graph a sequence. In this case, we're told that one term of our arithmetic sequence, so right off the bat we know it's arithmetic because we're told our 11th term is 24, and the common difference is 2. The first thing they want us to do is to write a rule for the nth term, then they want us to graph the sequence. So I'm going to rewrite my general formula that we used previously, dn minus 1. And in order to be able to use this to find our rule, we have to know what our first term is. Now in this case, we don't. All we know is what our 11th term is. So instead of working ourselves backwards and trying to figure out what the first term is, I can use this formula here to find my first term and then use the formula again to find my rule. So let's look at how we would use this formula to find our first term. Well, obviously, if we know that a sub 11 is equal to 24, our 11 is represented as our n, and this whole 24 is represented as our a sub n, when n is equal to 11. So I can plug this information in. So the first thing I want to do, I'll put first, is we want to find our first term. And we do that by plugging in the information or the pieces that we know. So we know a sub n is equal to 24 when our n value is 11. So we don't know our first term. We know that d is 2. And we know that n, when our a sub n is 24, is 11. So if I crunch these numbers, 11 minus 1 is 10. So if I keep simplifying, 2 times 10 is 20, so this reduces to 24 is equal to a sub 1 plus 20. To get a sub 1 alone, I subtract 20 from both sides. So I know my first term is going to be 4. Since I know my first term is going to be 4, I can now use my formula again to plug in these pieces of information, my a sub 1 being 4 and d being equal to 2, to find my rule. My rule, obviously, I want to leave a sub n open and my n open because I want a general rule. So if I rewrite this, I get a sub n is equal to my first term, which is 4, plus d, which is 2, times n minus 1. Simplify those values, I can distribute the 2. I get 2n minus 2. Crunch those numbers again. My constants, 4 minus 2 gives me 2 plus 2n, and that's my rule. From there, I now want to graph my sequence. Okay, so I already know where my first term is because I used that to find my rule. So I know my first term is 4. My second term, since my common difference is a positive 2, I know that my pattern is going to be increasing by 2. So I know my second term is going to be 2 more than 4, which is 6. I add 2 again to that, because I'm adding 2 as my pattern, I get 8. My fourth term should then be 10, my fifth term should then be 12, and my sixth term should then be 14. Just like I did in lesson 1, I'm going to plot my answers over here on my graph. These end up translating as ordered pairs, where my inputs are my n, my outputs are my a sub m. So I can rewrite all of these as ordered pairs. So if I write this as 1, this can be 2, 3, 4, 5, and 6. Going up, obviously they're going by 2, so this is 2, 4, 6, 8, 10, and 12, 14. And then I just plot my values. 1, 4 starts here, 2, 6, 3, 8, 4, 10, 5, 12, and 6, 14. All those numbers, we don't connect them with a solid line because the numbers in between are not part of my sequence or my graph, so I leave them as just dotted values. And if I notice, I actually have a linear function going on here. So those graphs of the arithmetic sequence gives me a linear function if I were to connect them with a graph, but I'm not. I'm leaving them as an open dotted graph. Okay, so at this point I want you guys to take some time and work on now you tries numbers 4 and 5. Number 5 has you graphing the sequence just like we did in example 3. Number 4 just has you working on finding the rule and the 12th term just like we did in example 2. So the next video will start up again talking about the sum of finite arithmetic series, and we'll talk about that in just a little bit. But right now work on numbers 4 through 5, and we will see you back in the next video.